All right, let's talk about something that drives us all a little crazy. We're surrounded by these amazing things that are supposed to look great and last, but so often they just don't. Today, we're going to pull back the curtain on the invisible force that makes our world peel, crack, and fade away.
I mean, it's a story we all know, right? You get that new car, that new phone, and it's absolutely perfect. And then, slowly but surely, the decay sets in. So, why does it feel like everything we own has some kind of built-in self-destruct button?
You know exactly what I'm talking about. Picture the paint on a car that's been around for a few years. That finish, which was once flawless, starts to get these tiny bubbles. Then those bubbles turn into peeling sheets, revealing that dull primer underneath. That's not just random wear and tear. It's a very specific kind of failure. Or, hey, let's make it even more personal. A dental filling. It's supposed to be this permanent fix, right? But then one day you run your tongue over it and there's a rough edge. A tiny piece has chipped off. The bond between that filling and your tooth just gave up. And of course, the modern tragedy we're all a little too familiar with. That screen is engineered to be tough, but one bad drop and boom, you're looking at a spiderweb of cracks. Now, here's the thing. A peeling car, a chipped filling, a cracked screen, they all seem like totally different problems. But what if I told you they share the exact same root cause? So let's start our investigation right here, at what you could call the scene of the crime. When our stuff starts to look old and worn out, what is it that we're actually seeing? Well, once you start looking for it, the evidence is everywhere. It starts with tiny little cracks that just keep growing. Then you see layers peeling back, kind of like an onion. That's a classic sign of something called delamination. Colors start to fade, surfaces get hazy or rough to the touch. You might even see little blisters or tiny flakes chipping away, a process scientists have a cool name for. They call it spallation. But remember, these are just the symptoms, not the actual disease. So what is this hidden force, this culprit behind all this decay? Well, it has a name, and it is the absolute heart of our entire explainer today. It's called bonding instability. Now, I know that sounds super technical, but the idea behind it is actually incredibly simple. At its core, bonding instability is just the failure of different materials to stick together the way they're supposed to.
Here's the best way to think about it. Imagine that almost everything you own, your car's paint, your phone screen, even that filling in your tooth, is made of different layers held together by a kind of microscopic glue. Bonding instability is what happens when that invisible glue fails. And when it fails, the world we've built starts to literally fall apart at the seams.
Okay, so how does this happen? What makes this microscopic glue just give up the ghost? Let's dig into the different ways our materials are constantly being attacked. What's the culprit's MO? It really comes down to four main attackers. First up is thermal stress. Materials expand when they get hot and shrink when they get cold, but they do it at different rates. That constant pulling and pushing literally tears them apart at that microscopic level. Then you've got chemical attack from things like moisture or salt on the road. Of course, there are also just basic mechanical forces, the daily grind of bumps, scrapes, and impacts. And finally, sometimes the problem starts before you even buy the thing, with flaws in the manufacturing process itself. And this isn't just theory. Science gives us the cold, hard evidence. For instance, studies on dental fillings show that something as simple as drinking hot coffee and then cold water creates these tiny microgaps that weaken the filling over time. Research on galvanized steel shows how corrosion doesn't just create rust, it actually makes the protective coating blister up and change color. Every one of these cases tells the same story. A specific stressor attacks the material, and the bond fails in a way you can see with your own eyes.
But here's the good news. This is not a story about inevitable decay. The really important thing to understand is that scientists are actively developing countermeasures to fight bonding instability, and this is where things get really, really cool. This table really tells the whole story. On the left, you've got the old way of doing things, standard coatings that crack, peel, and fail, often suddenly. But on the right, that's the future. We're talking about solutions that use unbelievably thin nanolayers to seal cracks before they even have a chance to grow, or using lasers to etch microscopic patterns onto a surface, giving it a much stronger grip. And the most incredible part? Smart materials that can actually repair themselves. So how do they actually do it? Well, it's a super methodical, four-step process. First, you prepare the surface perfectly, getting rid of any potential weak spots. Next, you prime it using advanced chemicals that create a much stronger connection. After that, you reinforce it physically, either with those microtextures or nanolayers.
And then, for the ultimate level of protection, you can even add in self-healing agents. And look, this isn't science fiction. This is the actual toolkit that scientists are using right now. Techniques like atomic layer deposition let them build protective coatings, literally one single layer of atoms at a time, which can seal even the tiniest cracks. And those self-healing smart coatings we just mentioned, they are becoming a reality. These are the technologies that are making our world more durable right now. So, what does all of this really mean for us? This research is paving the way for a future where the things we depend on every single day are fundamentally built to last so much longer. And let's be clear, this is about so much more than just keeping your car shiny. Think about it. We're talking about safer medical implants that bond perfectly inside the human body, more reliable electronics that can withstand the abuse of daily use, and bridges and buildings that don't crumble. Ultimately, it's about building a more sustainable world where we don't have to constantly replace things because they're built to perform better for way, way longer. Just let that idea sink in for a second. We are moving from a world of materials that just resist damage to a world of materials that can actively heal from it, restoring their own strength and even how they look. That's not just an improvement, that's a whole new ballgame. And it all leads us to this final, really powerful question. We might not be there just yet, but the science of bonding is pushing us closer and closer to a world where new isn't just some temporary state, but a lasting quality. What would a world that's truly built to last even look like? Definitely something to think about.